Hello everyone, this is Mr. Woods, and this video is for periods 1, 2, 3, and 5, the CPM 3. And it's been a week since I last communicated with you via Zoom. I did some examples of factoring difference of two squares and some difference of two cubes. So this video I want to do some more examples from your worksheet. So as you see here, the worksheet I'm talking about is factoring the difference of two squares. And I want to go over the work for 11, 23, and 29. So not only do I want to explain the process, but I want to explain what I expect to see for you to get full credit when you turn this in as homework. Because I also gave you the answers, not so you could just copy them, but so you could check to make sure you're doing it right. So when I show you these three problems, it also goes over the work that I want to see. So those of you that have completed this already, there are a few of you that have done that. I want you to go back and make sure that you've shown all of your work. So I'm gonna, on this side of the whiteboard, I have 11 and 29, because both of these fit. 23 is a bit longer, it's on the other side. So I wanted to do some that weren't typical factoring the difference of two squares. I want to do some where there are a few more steps. So if you look at number 11, you see number 3 and 75. Neither of those numbers are perfect squares. So in order to use factoring the difference of two squares, I first have to factor out a 3 from both. Then see what happens on the inside. After I do that, I end up with the difference of two perfect squares. So this is the first step. Second step, I want you to show this as part of your work, what makes each of these perfect squares. You have n squared, and then 5 squared is 25. Now, you show here, you specifically have the difference of two squares. You bring down the 3 as a GCF, and now you're ready to put it in a complete factored form, the sum of the two terms times their difference. So that is all the work for number 11. Now moving on to 29. So 29, you have 16 m to the 6 minus n to the 6. So notice here, what is different here is you don't have an exponent of 2, you have an exponent of 6. However, any exponent that is even, you can still change each term so that it represents the difference of two squares. So if you look at the first term here, what makes 16 a perfect square is 4. If you just cut 6 in half as the exponent, then you're going to have m cubed. Notice here, if you look at this, if I square this out, 4 squared is 16, and m cubed to the second power. Remember, with exponents, power raised to power, you just multiply, you still get m to the 6. So this right here is equivalent to this. Same thing with m to the 6 and n to the 6, you turn it into n cubed raised to the second power. Again, if you multiply these two together, you'll see that that exponent is 6. So now you see you have the difference of two terms that are squared. So once you have that, then you can turn it into the sum of these two terms times their difference. And now this is the complete factored form for 29. Lastly, number 29. That was 29. Going to 23, it's on the back here. Okay. So here you do have a minus sign, m to the 4th, n to the 4th. Those are perfect squares because the exponent is even. But look at your 125 and 20. Those are not perfect squares. So just like in a previous problem, what you want to do is factor out a GCF to then see if you can create two perfect squares. So the GCF between these two is 5. And you're left with 25 n to the 4th and the minus 4 n to the 4th. So now your 4 and 25, those are perfect squares. So your next step, I want you to show this, is turn this into 5m squared raised to the second power, and then turn this into 2n squared raised to the second power. So now you specifically have the difference of two terms that are raised to, look at this, to the second power. So remember, the GCF of 5 comes straight down. From this step, you take the sum of the two terms and then times their difference, and this is a complete factored form for 23. Right? Okay, for my odd periods 1, 3, and 5, you're going to have a quiz on Wednesday, April 29th, And then my period 2, you're going to have a quiz on April 30th. I'm going to give you a quiz through Google Classroom. It's actually going to be multiple choice. So it will cover factoring the difference of two squares, factoring the sum of the difference of two cubes, and then given a polynomial, tell me how many possible real and complex numbers, as well as two other review problems, solving a simple log equation and an exponential equation. So let me give you some examples of what I mean. So for example, move my arm out of the way. Right here, you have log base 7 of x is equal to 3. I want you to solve for x. And then an exponential would be something like this. 16 to the x power is equal to 64. Let me move my arm out of the way. Make sure you can see it because it looks like there's a light in the way. And then I want you to take this exponential equation and solve for x. So I'm going to see if you guys can do these two on your own, see if you remember, and then I'll have the answers on the next video. All right, enjoy.